All right, let's start. My name is Zara Bernardi. I'm with the remote desktop team. And today we're going to talk about designing VDI architecture for scale and performance. Large audience for 5 o'clock. I'll be exhausted by now. But thanks for showing up. Before I start, can I get a sense of people who've already played with VDI in 2012? That would help me pace the talk, you know. All right, so only a few have. So to most of you guys, VDI 2012 is new. All right, so I spent a little bit more time in the introduction section talking what are the features of VDI in Windows Server 2012. And then I'll get into the design of large-scale deployment and the performance and characteristics of such a system. And we'll drill down into actual results from our engineering lab in Redmond. So intro to Windows Server 2012 VDI. By the way, I'm going to cover some things from R2, but they're going to be preliminary. We're still testing R2 features, but anything that is relevant, I'm going to add to the mostly 2012 focused presentation. So, this slide basically shows a simple configuration within a CorpNet, and the building blocks are RD Web Access, which is a web service that we run, and typically users go to the RD website to see what applications or collections are published to them, and log in at the website and get redirected. I'll do a whole walkthrough of the login. The other building block is the remote desktop connection broker, which talks to a SQL Server backend and has all the state configuration for the VDI deployment, and that includes the active states such as where the user's logged on, where are the disconnected sessions, or just static information such as these users have access to these applications, or these are the servers within a farm. And then finally, we have a bank of servers, hypervisors that host either personal desktops or pool desktops. And also we include RDSH, the traditional terminal server, in the VDI mix, and that could be another option that the user can connect to. So building block, RD Web Server, RD Connection Broker, SQL Server in the back end, and then the infrastructure that runs on the hypervisors that provide the pool VMs or personal VMs. And then there's also the session host or the traditional terminal server. So in terms of connection, what happens is a user on the LAN connects to RD Web, logs in, user is identified, and RD Web gets a download of all the applications that this user has access to. So you see a page with icons and so forth. These are the collections or published apps that you can use. Then the user clicks on one of these icons, one of these application entry points, if you may, and a connection starts, RDP client starts running, and it connects to the broker. Next, the broker identifies the user and looks up to see where is the best place for this user to go to based on the information it has, such as user already has a disconnected session somewhere. So it sends a blob back to the RDP client running on the user side, and finally, RDP client will look at that blob and initiate a connection to the actual target. That's a high-level view of how VDI works in Server 2012 in a simple LAN environment. If the users are on internet, then we have this additional component, which is the RD gateway. It acts like a firewall. And there's an RD web on the internet facing, just like the RD gateway, that users connect to go through a similar process. So user connects to the RD web that is now facing internet, logs in, HTTPS. RD Web talks to the broker, gets all the information about what applications or collections the user has access to. Then user clicks on one of these items to get connected to that resource. And the connection goes through the RD gateway. So the RD gateway is acting as a proxy, and it's only letting RDP traffic go through, and it does a proxy to the broker again. User is identified by the broker, and broker looks up to see what is the best target for this user and sends a blob back to RDP client on the internet side, and RDP client initiates another connection, again through the gateway. that is proxy to the final target. That's the gist of connection from internet. Now, for those of you who happen to see Adam's presentation on Monday, this is a very tiny recap of a lot of stuff he covered, and you probably, if you haven't seen it, please take a look at his presentation. It's available online. There's a value spectrum for 2012, VDI 2012 that we offer. The most cost-effective are sessions. These are the traditional terminal server RDSH, where a single image is shared by many, many users, 100, 200, 300, and just updating that one image basically upgrades the runtime environment for hundreds of users. So from an ease of management point of view, RDSH rocks, because one image update really affects so many users or helps so many users. And that makes it also more cost-effective. You're managing less images. App compatibility, even though a lot of applications run on RDSH, sometimes some don't because of the multi-user nature of RDSH. And so the app compat scores only 2 stars. And there's also personalization, which is users can create, personalize or set the settings for their own environment. But because, again, it's a multi-user type environment, users do not have admin level privilege. So they can't make changes that are system-wide changes that are persistent. So from that perspective, it's a little bit less, it's less possible to personalize it compared to a desktop you actually own, right? Next one is the pool VM, which is in the middle. And pool VMs give you the best app compat because applications that are written for client SKU run on a client SKU, and these VMs are client SKU VMs. So you get the best app compat. Similar to RDSH sessions, you're not an administrator, so you cannot make machine-wide changes, and that's because these are pooled resources. And the point is that when the user logs off, that VM is reset, another user can log in. So the act of resetting basically eliminates anything that user could have done system-wide. Ease of management is a little bit worse than RDSH because you have to recreate, when there's an update to the pool, you have to regenerate the whole pool, which means you have to create maybe 1,000 VMs again. And because there's a single image per user, then it's more expensive to run these, the pool VM as a resource. Now, on the right-hand side is the personal VM, which is just like your desktop or laptop that you own and you're administrator on it. We can create that as a pool. It's a simple operation to create it, but from that point of view, it's managed like a real desktop. It's a Windows update has to run inside. There's no global way to update everything. It has to be updated within the VM itself. So that because these pool VMs are assigned to a user permanently, user can be admin, user can make changes to machine-wide changes, and everything persists. App compat is just as good as pool VMs because this is a client SKU. Ease of management and the cost effectiveness is the price you pay to have this kind of flexibility. So that's the spectrum. We really encourage you guys to look at, if you're looking at centralized desktop or centralized applications, publishing applications, RDSH will give you the best value. And then you go down pool and personal. There's no one solution that meets everybody's needs. Probably it's a mix of solutions, but take a look at RDSH first. This talk is not about RDSH, though. We're going to talk about designing a VDI architecture for pool and PD VMs. So when we're talking about perf and scale, it's important to first start with, well, what do we mean by perf? What are the focus of high-performant VDI deployment? There's certain things that are very expensive, like provisioning, creating new collections, updating collections. That's very expensive in terms of required resources. It takes a long time. But fortunately, you could run those off hours. IT admin can run those off hours. The login phase is also pretty expensive. So if you expect, for example, it's a task worker environment and everybody's supposed to log in at 9 a.m., you have 2,000 users, you're going to put a lot of stress on your storage, right? And then after that, it's your daily work period, the 8 hours or 10 hours. And typically, or more commonly, we focus optimizing for that type of workload. That when people logged on, the system is performant for the thousands of users that it's hosting, and we optimize it for that workload, right? The system load is very sensitive to usage pattern. So task workers, for example, need less CPU, generate less I/O than power users. When we test these or benchmark these, we use some kind of a simulation software. And these simulations attempt to generate the patterns that we think of for a normal power user, but they're just a simulation. As the saying goes, your mileage will vary. So the best strategy to design a VDI architecture for performance is really to understand what are your performance requirements. Maybe you need that 9 a.m. Everybody logs in within 5 minutes, and everybody might be 5,000 users. Or they're knowledge workers, and they can log in within half hour or 1 hour. So the performance requirement will be different for that type of user. And you estimate the system requirements based on the assessment you made of what kind of performance you need from your system, and you build and iterate. Now, when we're talking about our results, what we did was used a simulation software called VSI that it tries to mimic what or simulate what users do, power users do. Is the benchmarking scenario we use called medium workload with flash. And you get the slide, and you'll see the details. It's kind of hard to see the smaller details, but there are about half a dozen or so, or a dozen applications that run at various parts of this 12-minute period. And there's an automation agent within the VM that starts these applications, types stuff in, prints stuff in, starts flash, renders stuff. And there's another agent that is looking at how long it takes for things to come up. How responsive are these dialogues that the automation opens, and reports to a centralized storage. And there's some analysis that happens later on, and an assessment can be made whether these response times were reasonable under whatever load you ran, or they were not, right? So the VSI infrastructure consists of a set of launchers that launch thousands of users. They connect to your VDI. The VDI environment is prepared to run the VSI agent. And at the end of an hour, let's say, stress period, all the results are gathered and an assessment is made. If you want to play with VSI on your own, Franz is here from the VSI, and Omar also, they have a booth, and they have agreed to give away samples of their software, the pro version for 100 users. So you can actually simulate this in a smaller environment, see if you like it, and then run it for, I think, 2 months. So we use the VSI, and all the data that I'm sharing with you is the result of this particular workload, which is called the medium workload with flash, which we think is a typical workload for a knowledge worker. We have similar simulations in Microsoft that has a very similar signature. So let's do a walkthrough of 5,000 seat deployment. Let's say 80% of users are LAN and 20% are coming from internet. I'd say that's a typical configuration. And we'll look at various options, 3 different designs. We'll look at the performance characteristics of designs and what things to optimize. Now, if VDI infrastructure needs a management, some management services, those are the ones that I enumerated early on, such as the RD Web server, the gateway, and so on. The configuration looks like you would need, obviously, HA, high availability, continuous availability. So it means that you really have at least 2 hypervisors, the ones on the right, that are running at least 2 copies of these workloads on the 2 hypervisors. And there's you have at least 2 NICs that are either teamed or SMB can use multi-channel. So if one of the NICs fail, you don't lose connections, right? And these VMs are running from a scale-out file server, 2 SMB servers, and there's storage behind them. In this example, they're JBODs. You have a WAN traffic, you have LAN traffic, which is the RDP traffic, and you have storage networks such as the VMs in this particular case, but we'll put more stuff on the storage network later on. VLAN should work here. Just it's a configuration option, really. Or you can have multiple NICs if you wanted to. The gateway can handle about 1,000 connections per second. And this was from the VSI medium workload that was generating about 60 kilobytes per second. So each gateway could handle 1,000 connections per second. And in this configuration, we were running on Dell R720s with a E5 2690 CPU. And each gateway had 4 cores and 8 gig of RAM. So that gives you a sense that 1,000 users, this kind of workload, what kind of resources you need for the gateways. The RD broker, same configuration, as in the same infrastructure, can handle 5,000 connections in less than 5 minutes. It depends a little bit about the collection size. The larger collection, it'll take a little bit longer. Smaller the connection could be half a minute or whatnot. You need 2 RD brokers in order to have high availability. We use a round-robin DNS. And here's an example of 50 concurrent connections in 2.1 seconds if you have 1,000 VMs in that collection. Because most of the work is done by the SQL Server, 1 core is sufficient in this configuration for the broker, and 4 gigs is what we threw at this broker. The load on the SQL is not that great. I'll have slides about how much load we actually generate on the SQL. But here, the database is small, 60 megabytes for 5,000 seats, not that much. Adding VMs, which is the act of creating VMs, provisioning VMs, is a bit expensive. That takes time. Not for the SQL, but for us. But 100 VMs takes about 1,100 transactions. But that happens during off hours. During the connection time, when users are logging in, that's where we put some load on the SQL Server. Again, it depends if everybody is logging at 9 a.m. within the first 5 minutes, or they take half hour to log in. And the load we put on the SQL Server is about 222 transactions per user. And the SQL team recommended 4 cores and 8 gigs. This is, again, on the E5 2690 hypervisor. These are virtualized VMs, virtualized workloads. And that's what we configured. And the load was, at least the testing we did initially, which was for one hour period, was insignificant. I'll have slides on that too. Things to tweak. In 2012, we, by default, when we provision or update VMs or collection, it's 1 VM at a time. That can take a long time. In 2012, we have a PowerShell option for setting what's called the concurrency value. And if you set that to 5, assuming your storage can handle it, and at the scales we're talking about, your storage probably is quite good, it can, then you can provision about 2 to 3 times faster. In 2012 R2, we're trying to improve on that, and we've tested, just last week we tested, if the limit is set to 20, we'll get a 5x, 6x type performance. So provisioning that took 4 hours would complete in less than 1 hour. Next, VDI, compute and storage nodes. So we'll discuss 3 design options. One, the compute node has local storage, so it doesn't use centralized storage. Think of it as a pod that has compute and storage together. Second design would be pool VMs that use a centralized storage, SMB scale out. And finally, a mixed up pool and PD deployment. In the first example, which is pool VMs running from local storage, we have the hypervisors on the right, n number of hosts. I think for 5,000, we ended up using or calculating about 35 hosts. We tested up to 2,000, which I'll share later. But the configuration was an Dell R720, same CPU as before, E5 2690. And there's a rack of 10 local disks, 15K RPM, configured in RAID 1+0. And 2 disks for the local operating system to boot from. And there's no storage traffic on the network because everything is local. VMs are booting from local storage. Redundancy doesn't really matter in the sense that if the hypervisor goes down, you lose a few hundred VMs, but those few hundred VMs are pooled VMs or shared VMs. They're not personalized until user logs in. So then the load will be absorbed by another hypervisor. So we don't need to cluster the the hypervisors, so you don't need to work clustering. And you don't need shared storage because the next VMs on the other hypervisor will boot from their local copy of the diff disk and the gold VM. But in order to personalize these VMs after user log in, there's a roaming profile, there's user docs, and user VHD, and that's being served from the scale-out file server. So in this configuration, we said, okay, a typical workload, typical workload is the medium workbench we're using from VSI. In a typical environment that nobody wants to oversubscribe their resources, we'll see if we can, how many users we can host if we keep the CPU about 80%. This will allow for spikes. User pattern is really different than these simulations. And we figure 20% overhead is sufficient to make it realistic. And within that bound, we ran the VSI benchmarking, and we could handle 150 users easy. This means that 150 users running on a R720 with a E5 2690 CPU, about 1 gig per, can share the same hypervisor environment, and they will see no degradation in performance. And you have 20% overhead in case somebody is doing something different than this simulation that is attempting to be a typical knowledge worker scenario. That says about 10 users per core. Okay? And the memory consumed, the VMs we used were Win8, x86 running Office 2013. And 1 gig per VM, and some memory for the hypervisor, and some overhead in case VMs need a little bit more. It says 192 gigs is plenty. The RDP traffic on the LAN from this VSI benchmarking is about 500 kilobits per user. So that says a 5,000 seat deployment will generate only 2.5 gig of RDP traffic to your data center on the switches that are bringing the user traffic, the RDP traffic into your data center. The traffic from I'll get to that later. The traffic on the user VHDs are minimal in terms of network load, but it has some bearings in terms of the IOPS of the shared storage. Okay, back to the local storage. So this is the CPU and the storage together. And 150 users, each user generates 10 IOPS. That says the disk infrastructure has to handle about 1,500 to 1,800 IOPS per second. The distribution, because these are pooled VM, most of the reads go to the gold VM, which is easy to see on the graph. The diff disk gets some reads and a lot of writes. And the user VHD, which is one way of bringing the user's profile and settings and documents to the user, takes about 400 writes per second. It's mostly write heavy. The storage sizing, the VMs, each one takes about 5 gigs of storage space for the diff disk. And the gold VM is about 20 gig. That says altogether, a few terabytes should be sufficient to have several collections. These are several gold VMs, and 150 or so users per that storage array, which is per VDI host. The load on the centralized server for the user settings is significant, though. It's all relative, of course, but 2 IOPS for 5,000 users, that says 10,000 write IOPS on your central storage. So if you're configuring with user VHD, a typical SMB server with a typical storage probably won't do it because the VMs are running really live from this shared storage, and that the load they're putting on this shared storage is pretty significant. One option would be to use roaming profiles, because roaming profiles just make a copy, and then when the VM is running, it's really running locally on the local storage, right? The actual load on the network from the user settings in this configuration, which is user VHD, is insignificant. So your data center, the network, a storage network, won't have much load due to user VHD. It's the IOPS that makes it a bit of a challenge. In terms of sizing for user VHD, 10 gigs per user for their documents and settings seems a good number. That says your central storage has about 50 terabytes, delivering at about 10,000 IOPS, write IOPS, right? And overall network load, not much different than before, a little bit more, but that's only storage load, 0.5 gigabits per second due to 5,000 user VHD users. Now, tweaks and optimizations. For the pool VM, as many of you know, there's a gold VM or common VM from which there's a diff disk for every one of the VMs that are running. So about most of the reads from the previous graph, about 70-80% go to this gold VM. So if we use a SSD for the gold VMs, then we can reduce the load on the spinning disks by about 45%. So one option would be what I described earlier, 10 disks, 15K, and all the load is on that disk, including the gold VM. Another option would be to use 2 SSDs and 6 15K disks. This way, the SSDs are absorbing most of the read operations. Now, since the 10 disk can handle just fine, you'll ask, well, why am I suggesting SSDs? Well, because if the scenario is such that logins are supposed to complete within a short period, logins are very read heavy, and putting SSDs is one way of solving the problem of, say, 5,000 users. That's about 150 users per hypervisor logging in within the first 5 minutes. So the SSDs become necessary. The other reason you might want to look at the SSDs is because these blades, they won't take more than 12 or so disks. And if you're going to host more than 250 users, then you have to put in SSDs in order to support this type of read IOPS. Next, let's move to same deployment, but without the local storage, all using centralized storage. Okay? Similar picture to the previous one is just that the hypervisors don't have local storage for the VMs because all the VMs are running off the network, off the SMB server, right? So in this deployment, we have 3 shares. User VHDs, like before, are on one of the shares. VMs are in a different share, and potentially there's a storage for gold VMs as the 3rd share. And the centralized storage has got all the spindles you need for this kind of deployment. Imagine you grab all the spindles from all these hypervisors and throw it in a centralized array for supporting centralized storage for this deployment. The load is really the same. It's just the aggregation of all the 5,000 VMs, right, against one centralized storage. The signature is no different. It's just that the load is much higher, right? So you might ask yourself, well, why am I doing this if now I have to put together all these spindles into one storage, centralized storage, and put this kind of traffic on my network, right? The traffic is significant. The size is significant, but that's the same size as before. The traffic is significant. It's 30 gigabits per second for the VMs running off the storage. So you ask the same question again. Why so much network traffic on my storage and the same arrays I'm putting in the central storage? Why would I do this? Because there's some tweaks which will reduce the IOPS you need. I'll get to that. So the central storage is through SMB scale-out. SMB scale-out uses CSV. CSV has a new thing in 2012 called block caching, CSV block caching. And the CSV block cache basically caches the gold VM in memory, in effect. So it's a per collection feature. It's a per handle feature. And it reduces the IOPS on the deployment by about 45%. So earlier, we were talking about what the load is on the 5,000, the load generated by the 5,000 VMs. That ends up being 50,000 IOPS. But with CSV caching, you can reduce the load to 30,000 IOPS. So you see the math that we did, we said, well, it's like saying all these hypervisors, their local storage is centralized, and why am I doing this, generating more traffic on my network? It's because now you can use CSV caching to reduce the effective 50,000 IOPS that was distributed across all of your hypervisors to 30,000 IOPS. It's going to cost you some memory. You have to use a CSV cache. This experiment used about 1 gig per collection. So if you have 100 collections, you need 100 gigs of memory on the SMB, on the cluster. SMB scale out is a clustered SMB to get this kind of performance. Now, you say, well, okay, so why would I use SSDs versus CSV caching? What's the difference? They seem about the same. They are about the same. CSV cache uses server's memory. It's really fast, but it's limited. Depending on the number of collections you have, you're going to run out of, if you have, say, 100 collections, that's about 100 gigs in each SMB server. One way of complementing the memory you have on the SMB server is by using SSDs for the gold VM. That would effectively deliver the same thing. One centralized, so instead of having 2 SSDs per hypervisor, you have 2 SSDs in your centralized location, maybe 500 gig, that's about it, right? Because each gold VM is no more than 20 gigs. So centralization, even though it has it puts extra burden on your storage network, has the advantage that you can use less costly storage by using servers, SMB scale-out servers memory, and also a small number of SSDs for the gold VM. To tweak in 2012, so in this scenario, you have tens of hypervisors hitting 2 SMB servers, scale-out servers. You want to make sure there's a load balancing going on so that one SMB server is not underutilized while the other one is overused. And there's a command line option for setting this in 2012. In R2, this will happen automatically, so you don't have to worry about load balancing. SMB optimization will do this automatically. All right, next, let's move to a mixed environment of pool VMs and PDs. Similar server, same servers. We use the R720 E52690 CPU servers. But unlike the pool VMs, these servers are now in a cluster. The reason they're in a cluster is because we're hosting some personal VMs, PD VMs. And if a PD goes down, a hypervisor goes down, we don't want the user to lose their work, which means another hypervisor on the same cluster will start the same VM. Therefore, the deployment of the VDI host must be clustered. Fortunately, in this hypothetical 5,000 VM deployment, we're well below the maximum number of HA object managed in a clustered environment, which is 8,000. And to do 5,000 seats, you need about 30 or 35 hosts, which is well below the 64 maximum number of hosts we can put in a cluster in 2012, right? The I/O signature, same, 5,000 generates a 50,000, except the distribution is a bit different. There's no gold VM that you can throw an SSD on it to absorb the load generated, the read load that is common, because PD VMs don't have a common parent, right? So your pool VMs, in this example, 4,000, we'll generate 80% of what we had talked about for the 5,000, so about 40,000 IOPS. PD VMs will bring another 10,000, but there's no sharing going on between these two, so there's no optimization there. PD VMs are also quite a bit larger than pool VMs. 100 terabyte is common. So for a PD deployment, 100 gig is common, so for 1,000 users, your centralized storage must be able to handle this size resource consumption, right? 100 terabytes just for the PDs. The rest of the number for pool VMs are similar, which turns out to be about 60 terabytes for the pool VMs and user VHDs and so forth. The traffic in your data center hasn't changed much. because all these VMs are booting off the network. The storage traffic is significant, is about 35 gigabits per second. That means you need to have HA network, 2 paths at least. So if one of the paths fails, your whole deployment doesn't go down. And as far as tweaks goes, PDs, there are no tweaks in 2012. So the best you can do is leverage some kind of dedupe in hardware or in SAN to reduce the amount of storage PDs need. But in 2012 R2, now we have live dedupe of VDI VHDs. For those of you who saw the keynote, there was a short video on this. And so far, our early testing shows that the size of the storage is reduced by 80%. So instead of 100 terabytes, you can do with 20 terabytes. And we've had enough time to test the boot cycle of these VMs. And the boot is actually faster because we are caching stuff in memory. So if you guys are interested, see that session. There'll be a lot more information about how the system works. It is a complex system, so it doesn't have seamless integration with VDI yet. So if you decide to use, if you decide to deploy PDs and would like to take advantage of dedupe, it's important to understand how these two systems can work together to deliver this performance. It's not integrated solution yet. And the last word in terms of sizing is vGPUs. Pool VMs and also PD, personal desktops, can use vGPUs. And we have a simple math that looks at the number of displays that the RDP client is supporting, the user is connected to, and the resolution, and do a computation. And we won't start a VM if the GPU is out of the minimum it needs to support that VM. There's a chart there that describes how much memory the GPU needs for a GPU-based VM to start. As far as runtime scaling goes, we've done some testing. Dell guys have done a lot more testing that they will be sharing in their session tomorrow at 8:30. Where's Senthil? I've noted what their session is. But anyhow, our testing shows on a Fire Pro 4 gig, we can handle 70 VMs. And if you plug in 2 Fire Pros, we can handle 100 VMs using the GPU. The second number that I'm telling you about, the 100, is because our test environment didn't have enough hypervisor memory to support more. But if you just do the calculation, it says 70 VMs per GPU, 140 VMs per 2 GPUs should work. Okay, to recap, we described 3 different types of deployments and the VDI management for that deployment. What's in blue is constant. Doesn't matter what kind of deployment you use. The load you generate on the network, the RDP load is the same. The number of hosts you need is the same. And the number of infrastructure hosts you need for the management service is the same. What changes is traffic on the network, how heavily your storage network is loaded, and what size of a storage you need for pool VMs, PD VMs, and so forth. So the white stuff are the variations between these 3 different types of deployments. With that, I'm going to jump into some actual data from our lab in Redmond. And this is a 2,000-seat pool VDI deployment on 14 VDI servers in collaboration with Dell. Our goal was to build 5,000, but we ran out of money to buy VDI servers for the 3,000, so we did a 2,000-seat deployment. This is what the actual deployment looks like. It's a complicated, bit complex chart, but it'll be in the slide. Basically, this is the concept of CPU, compute, and storage being local. So all the VMs are pool VMs running from local storage. None of the hypervisors on the VDI host side are clustered. The traffic between the VDI host and the SMB scale out is really the roaming profile traffic. We use the roaming profile traffic in the roaming profile option in this case. And there's an iSCSI to the Equalogic SAN server for all the user data, SQL data, and also for the infrastructure VMs that are running off of the SMB server. So the first thing is that we had no trouble running. This chart shows basically, this is, remember I mentioned about the VSI benchmarking that reports response time to a central share, and there's a process that runs on that share called analyzer and displays what the response time of the VMs were as the number of VMs were increasing for the whole infrastructure. And here we were running 2,000 VMs of logging in at the rate of 2,000 users in 60 minutes. VMs were x86 Win8 running Office 2013. And you see that it never exceeds what is a reasonable number for the aggregated response time. It's called the VSI max. And this chart says the VSI max was not reached, which means your system could do more. We just happened to do 2,000 because we had license for 2,000. Okay, next is the load on the SQL Server. Remember I said the load on the SQL Server is not that bad? So this is 2,000 connections coming in the period of 1 hour. You see the middle bump in the SQL Server. This is the disk I/O on the SQL Server. And in this period, we're using about 2.5% of the CPU. This is 1 hour period. And disk I/O is just nominal because it has enough memory to load the whole database in memory and do all the transactions in memory, right? And the broker is just doing no work. We happen to throw 2 vCPUs on it, but that's an overkill. 1 vCPU with 2 gig of memory would have been sufficient, right? Now, if users were supposed to log in, 2,000 users were supposed to log in 5 minutes, what would happen is that that rectangle would just collapse to a 5 minute, and it would be straight up, and it would be 60 or 50 times the 2.5. So you'll use about over 50% of the CPU on the SQL Server for that 5 minute period. Then there's no load on the SQL Server. And the reason I mention this is because typically in an enterprise, there's already a SQL Server. And our pitch is, use the SQL Server already deployed, right? You don't have to deploy another SQL Server for us. And having this characteristics will help you. It says, what is the load you're going to put on that SQL Server, and when you're going to put that load. For that tight login period is really that 9 a.m. slot. And after that, it's down to 0. Next, let's look at one of the 14 hypervisors that is hosting 150 VMs. Okay? The red line is the CPU. The CPU is about 75%. We said we wanted to keep it under 80. It's about 75%. The disks are the local array, 10 disks, 15K, RAID 1 plus 0. And the yellow segment is the part of the graph where the login is happening. That's the 1 hour period. After that, the workload, not after that, during that period, the workload is building up. Users log in. Within the first 10, 15 seconds, the workload starts, and then another user logs in, so on. So the workload is running in that period where there's a yellow circle around the response time of the disk, but also users are logging in. And that's the heaviest part of the load on the storage, right? And you see that the disk I/O is about 1,000 read IOPS and about 700 write IOPS, and response time of the disk is quite reasonable. 0 is a reasonable number to me. No time to respond for writes, and 6 milliseconds for the reads. This tells you, or tells me, tells us, that we can actually drive these hypervisors further, and the storage can handle more, right? So how far can we drive this design? More VMs, faster login. So in this test, we had 205 users logging in 35 minutes, okay? And we hit the VSI maximum, meaning the system was starting to hit the tipping point. 205 users were logged in, but after about 200 users, or 197 users, the response time started to degrade. The point here also is that the disk can handle storage load of about 3,500 IOPS. And this is what the response time looks like. After about 197 VMs running the benchmark workload, response time became above the reasonable average for interactive user. The challenge with VDI is that users click on things and they expect a response of that, that thing to respond. So there's a response time within which if you don't not respond, then the system is sluggish. And what VSI tries to measure is when did the system appear to be sluggish to end users. And there's in this example where the system was really being driven to a tipping point, 100% CPU, 35 minutes, log in for 205 users, then using the example of 2,000 or 5,000 users, right? We're saying that everybody was logging in this 35-minute period instead of the 1-hour period, and the system was becoming unresponsive. I happened to push this further and noticed that disk was becoming a problem. So this is where you would say, well, I need to put in 2 SSDs because my task workers or even my knowledge workers have to log in within the first 5 minutes, not 35 minutes for the 2,000 users logging in. All right, so another important consideration is, since you're talking about performance and scale here, is that Office 2013 versus Office 2010. Office 2013, great experience, touch-friendly, but it has a cost, and the cost is CPU, and it's 20% more CPU usage. So the same configuration, driving it to the tipping point. With Office 2010, we could support 235 users before the system became sluggish, before the response time became unacceptable. With Office 2013, that happens sooner because it needs more CPU, and the number was about 197. So that's another consideration about the workload. If you're going to use 2013, remember it will need more CPU for Office. All right, some data about our broker and provisioning. If you start playing with VDI, we don't require a SQL server. You can use WID, which is a database built-in Windows server, and a single broker. In this chart, what I'm showing, the blue line is a single broker, 50 connections coming concurrently. It takes 3.5 seconds to figure out where the user should go to. As soon as there's a SQL server, that connection, the time to figure out where the user should be routed to drops to about 2 seconds. Beyond that, it doesn't really matter how many more brokers you add because broker is not doing the work. It's the SQL server that's doing the work here, right? And this chart also has, for comparison, 20 concurrent users coming versus 50 concurrent users coming and what the response time looks like. This is the time that the broker takes to figure out, with the SQL server's help, to figure out where this connection should go to. This is about the concurrency I mentioned that in 2012, by default, we update, create 1 VM at a time. If you increase the concurrency value, the updates can go faster, but you need enough CPU and storage to be able to do this. So if the storage can handle it, do increase it. And my hypothesis is that when we're talking about this type of a deployment, your storage will be able to handle it. But my teammates were too nervous, too concerned that we could not guess what's the load on the system. Therefore, we should start with 1 and let the admin set the values to something higher. In 2012, the high value is 5. We had some issues which we're resolving for R2. And R2 right now, with the fixes we have, the value can go as high as 20, which means 20 VMs can run at the same time when they're being created, updated, provisioned. They share the CPU. We still serialize on I/O. That's why we're starting to hit this curve is going like this, because I/O becomes a problem for us. So IOPS due to VDI medium workload. The only reason I put this chart up here is because if you look in internet for trying to assess what kind of I/O should you consider when you're designing your storage, there are numbers all over the place. And here's a chart for you guys that if you look at the chart, at the line which says yellow, 110 VMs, there's no load on the system, and you do the math and you look at the counters, it's 10 IOPS per user. You can be confident that 10 IOPS per user is a good number to use when you're doing estimation, when you're talking about a typical medium workload. Matter of fact, in our team, we have another workload generator that is, in some sense, similar to VSI, but it's a different workload generator, nothing to do with VSI. And we use that to create or simulate a knowledge worker environment with video. There's Flash, there's Windows Media Player, Silverlight, whatnot. And we see about 10 IOPS per user also. So 2 different simulations that both have attempted to model a typical knowledge worker have the same I/O load, 10 IOPS per user. Okay, so the purpose of this slide is to give you guys some insight about the interplay between host memory and storage. It's not all happy day stuff. You just put it back on the envelope and things work. And this type of information, I'm hoping that it'll help you size your deployment better. And in this chart, which is a bit complicated, we have a DL585, which is a pretty high-end machine, 12 by 4 cores, 128 gigs of RAM. And you see that we basically start logging in users. The green line is the partition. And we go to about 228 users. Okay? The available memory is starting to drop on the hypervisor. And you see that about 2/3 of the chart, the load on storage is average, nothing significant. And then around this time, which is 6:25 p.m., we see sudden jump in the number of reads to the gold VM, and also to the disk, the diff disk writes and diff disk reads, right? So you say, okay, so what's going on here, right? The hint is that the available memory on the hypervisor dropped to 0. So what happens is that when the hypervisor's memory drops to 0 and hypervisor's dynamic memory is enabled, hypervisor will squeeze memory out of all guest VMs. So as the memory of the guest VMs is being shrunk, which is the top chart, guest VM is flushing stuff to disk, right? So you basically are trading hypervisor memory to disk performance. Because now guest VMs save less in cache, they have to go to disk more often, right? So you made that trade. So the 10 IOPS we talked about, that breaks down when dynamic memory starts flushing stuff out of guest VMs to disk. Your disk must be able to handle more IOPS. So if I had to trade between dynamic memory, the server's memory, and disk storage, I would put more memory on the host in order to alleviate the demand on storage, because storage is the most expensive part of this equation. Okay, so this chart is about CSV caching. Remember, we talked about the benefit of having centralized storage. Why would I pull out all, figuratively speaking, all these spindles from each hypervisor and put it in a central storage and increase my storage network? Well, because you can use CSV caching. Well, what's the benefit of CSV caching? Here's the chart that shows the benefit. So here's in this example, it's 40 pool VMs starting from off state. So it's a boot. It's basically a boot storm, which is very I/O heavy. And you see that the top chart shows the cluster I/O reads, and these are all the I/Os that are coming to the CSV, and CSV must satisfy. The red chart, the red line shows the I/Os that are satisfied from CSV's cache. So most of the I/O are satisfied. And some of it are not, which is the green light, which goes to the green line that goes to the storage. So this is a CSV cache. This is a demonstration, a chart that how significant impact the CSV caching has, and why it is beneficial to use SMB scale out in a centralized SMB server type deployment for your VDI, because you can get this kind of benefit from centralized storage. The extra cost is higher traffic on your storage network, but that's restricted to your data center. It's not to your users, right? And here's an example, similar example, 100 VMs running the VSI medium workload. The one on the right, CSV cache is enabled, and the one on the left has CSV cache enabled, and the one on the right doesn't. And the green line and the blue line, these two lines, you see that indeed when the CSV cache is not enabled, the load on the storage is higher. And when it is enabled, the storage load is a lot lower. So one thing, it's in one of the earlier slides I forgot to go over, is that if you're storage bound, meaning your deployment can host X number of users because you're hitting the storage limitation, CSV caching will increase the number of users by 20%. So the numbers we're seeing is that if storage is bottleneck, you enable CSV caching, so your deployment is of the type that can benefit from CSV caching, which means centralized storage on SMB, then you can host, assuming you have the CPU, 20% more users, right? So 2,000, 5,000 deployment, you can have 1,000 more users if you have CSV caching enabled on the SMB scale-out servers. So this is the SMB network traffic. This is, let's see, we have, I think, 100 VMs, 95 VMs. And this shows the IOPS, which are pretty much the same as we were talking about the IOPS on the local, but it shows how much traffic we put on the SMB. The cyan is the writes per second, 25 megabytes. And the pink one, scale is different for each chart, each line, is the read bytes per second, 60 megabytes. This is how you add this up and sum up, and you see that your storage network must sustain about 30 gigabits per second traffic to support a 5,000 VM deployment. All right, and this is the last complicated slide. It's getting close to 6. So this is about the vGPU, right? So let's look at the left-hand side, which is a single GPU on a hypervisor. And the red line is a chart of users logging in, and the load on the hypervisor is going up, and you get about 82 VMs. The kind of brown-green line in the middle is the system memory that starts with 50 gigs and starts going down as more and more VMs start running. And the cyan is the GPU on the single ATI V980, which is 4 gig. And we see that the GPU runs out of memory right about there. There's a spike, and when that happens, we can't create any more vGPU-based VMs. The response time of all the users all up to that point is fine. It's just, we have 82 VMs running, no problem, or 81 VMs running, no problem. The last VM comes, VM number 82, it can't start, but users are not affected. They're running just fine with the vGPUs they have, right? On the right-hand side, it's the same system with 2 vGPUs. But the system doesn't have enough memory for the hypervisor. So what happens is that the way the vGPU system works is that we actually use processes on the parent partition to render the content from guest VMs. So what happens here is that hypervisor starts running out of memory and starts swapping, even though the GPUs have plenty of memory. So when the hypervisor is out of memory, we start swapping these rendering processes that are responsible for rendering content of all the guest VMs. So the user experience in all guest VMs suffers. So there's a breaking point if the hypervisor runs out of memory before the GPUs run out of memory, is that hypervisor will start swapping and will affect the rendering processes. We have one per VM. They're swapped to disk, and the response time in the guest VM using the GPUs goes to hell. So keep an eye on how much memory is available on your hypervisor if it starts swapping, if you have less memory than the memory in the GPUs you put in. This was the example that we had earlier. We talked about 70 VMs. We were tested just fine, but we stopped at 100 because our hypervisor went out of memory, even though we could have done 140. And on closing notes, we have an inbox PowerShell that we've tested, simulation tested to 5,000 seats. I've shared with you guys benchmarking we did for 2,000 seats. We were hoping to do for 5,000. We ran out of funding. We have an inbox UI that is designed to do only 500. These are the sessions that I recommend you guys either checking out if they haven't occurred yet, or watch them online. The one on deduplication would be very interesting. There's one on tuning images for VDI. Dell guys will have an interesting talk which includes more information about GPUs and other cool stuff. And Adam's, the first one is Adam's infrastructure talk, which is a great talk if you want to learn about VDI end-to-end. We have a blog. Check it out. We post there often. We're doing less white paper and more blogs. And this is all goodies that just appeared in my slide. So probably you've seen these already, so I'll just go through real fast. And gifts for you if you fill out an evaluation. And questions? At 6 p.m., please.
So you mentioned about vGPUs. Are those 3D rendering optimizing?
Yes.
That's quite impressive numbers. You really have.
Thank you. VGPU guys, we're very happy to hear that. Other questions?
Who's the gentleman that has the free?
Oh, yeah. He's right there, standing with the card in his hand. Franz. Other questions? Thank you.